A dish that is aligned to a satellite in 68 degrees east, Nigeria will tend to face somehow this way. Welcome back to our channel. We are still on the Satellite TV Masterclass. Now today we'll be talking about orbits around the Earth. Now we have different types of orbits. First and foremost, we have what we call the low Earth orbits. These orbits are used for Earth observation imaging, low latency internet, e.g. the Starlink that is around the world, and weather monitoring. We also have medium Earth orbits. They are used for GPS, Galileo, Beidou, GLONASS. That is, they are basically for navigation. But the orbit of interest to us is what we call the geostationary orbit. That is number 3. Geostationary orbits. This orbit has a different name from the other two we mentioned earlier. It is called geo means Earth, and stationary means something that is not moving. Does it imply that satellites on this orbit are not moving? No, they are always moving. Now take for example, this is the Earth, and there is an orbit around it. Now, for this particular orbit, this is the equator. Since the Earth is in 3 dimensions, this orbit falls into the equatorial plane, more like a plane. This is the equator. It falls into the equatorial plane. It means that it is on latitude 0 degree. Now, a lot of people mistake angles on their dish with satellite longitudinal angles. We'll get there. Now, this particular orbit falls into this equatorial plane. Now, for a satellite on the equatorial plane, this satellite revolves around this. The satellite revolves around the Earth at a speed of about 11,000 kilometers per hour. 11,000 kilometers per hour. That is a high speed, but yet the satellite appears to be stationary. So that is why you don't have to move your dish every now and then to align to the satellite. Once your dish is locked onto a satellite, it is locked onto. Now, why do we call it geostationary orbit? It is called geostationary orbit because the time this satellite revolves around the Earth is the same time it takes the Earth to rotate about its axis. You and I know that the Earth rotates about its axis. The Earth rotates, that's why it accounts for day and night that we experience in different parts of the Earth. So you and I know that the Earth rotates about its axis, it spins. Now, for this, it takes 23 hours, 54 minutes, and about 4 seconds or thereabouts to complete one rotation, that is the Earth. The same thing is also applicable to the satellite on this orbit. It takes that same time to revolve around the Earth because it's moving at a very high speed, 11,000 kilometers per hour. Now, let's look at the parameters of satellites on this geostationary orbit. Like I told you earlier, it revolves at a speed of approximately 11,000 kilometers per hour, which is 11,052 kilometers per hour. Now, the time it completes its revolution, actually it revolves around the earth, while the earth rotates about its axis, is 23 hours, 54 minutes, and 4 seconds. Now the altitude that is the height from the equator is 35,786 kilometers. That is the altitude. In the description, we'll put other parameters that concerns this satellite. Now, we have to talk about something that so many people confuse a lot. We'll talk about satellite orbital position. I told you that this satellite, this particular orbit, is in the equatorial plane. Therefore, it does not cover all parts of the earth. We'll discuss that later. So, it's in the equatorial plane. But now let's look at why different satellites have different angles. You and I are aware that the earth itself is divided into longitudes and latitudes. Now this is the earth. This is the equator. I have the north, the south, east, west. Now, for here, this is the equator, which is latitude 0 degree. Latitude 0 degree, where the plane where geostationary satellite is. Now, look at this. There are lines of longitudes. There are lines of longitudes. There are lines of longitudes. There are lines of longitude. Now, for this particular satellite now, for satellites on these orbits, there are lines of longitudes. These are lines of longitudes. Since the earth is three-dimensional, it is spherical in nature. So it means there are lines of longitude round about it. Now, take for example, the satellite the orbit we're talking about in the equatorial plane. This is the equator. I'll have a satellite here. We have another satellite here. We have another satellite here. So let's assume that this satellite here is aligned to this line of longitude, and let's call it satellite 28.2 degree. Take for example, this is the angle for Astra 2. Now we have another satellite here, aligned to another longitude. All of them are in the same plane as the equator, but aligned to this longitude. Let's call this 36 degree east. That is the satellite for DSTV. Now you can see that these lines of longitudes here, there are satellites that are aligned to it. So that's why somebody can confidently say that that satellite is 42 degree east, that satellite is 36 degree east, that this satellite is 7 degree west, because there are also satellites aligned on this same plane, aligned on different longitude. So a lot of people confuse the angle on their dish for satellite longitudinal angles. A lot of people confuse that for satellite longitudinal angles. So that is why at different points in Earth, like this is Nigeria. Nigeria is somewhere here. Nigeria is somewhere here. Somewhere here. Because Nigeria is somewhere here. Nigeria is somewhere here. And South Africa is somewhere here. Now that is why a dish that is aligned to 68 degree, aligned to a satellite that is 68 degree east, that is the Intelsat 20 satellites. In Nigeria, we tend to face somehow this way, pointing down, because that satellite is farther away. Because as we move closer to the higher longitude, as you move closer to the higher longitude, the dish will tend to face down in order to see it. Now take for example South Africa that is here. Now if you want to align this same satellite, you will find out that here in Nigeria the satellite is facing down, but in South Africa the satellite, the satellite dish will face up. The satellite dish will face up. That is why you see, for this same satellite, somebody in South Africa will face his dish this way. Somebody in South Africa will face his dish this way, facing up. While somebody in Nigeria will face it this way, which means they have different elevation. They have different elevation. Now, come to talk about the azimuths. That is moving your dish sideward. Now, because the Earth is spherical and satellites are aligned at orbital angles, you then have to align your satellite to a particular satellite by moving it sideward and then upward to capture the elevation. Now, in subsequent videos, we'll be talking about this in details. Just stick with us. By the end of this satellite masterclass, you will learn a lot about satellite TV that will blow your mind. We're not rushing. We'll get there. Thank you for watching. So if you are viewing our video for the very first time, please hit that subscribe button. Like this video to promote it so that more people can see this. We are forging ahead. By the end of this 10 lessons class, we are still in lesson 2. You will learn a lot about satellites. We'll be practical, but the theory is important for you to get first. Please make your research on what we have done so that you don't end up learning only what we have done. Make your research so that you will be well informed. Ask questions where necessary. Any question that bothers you in respect to this, please ask your question. We'll be more than happy to attend to your question. Thank you for watching. See you on the next video.